Hi everyone. In this video we'll actually draw a pushdown automaton and we'll take the language that we've been considering for a while, which is a to the power n, b to the power n. So we want to draw a pushdown automaton for this. What we want to do is we start with a start state, which is, let's say, q0, and we say that the start symbol for our stack is z. So my stack already contains z. And what I want to say is, until I keep getting A's, I want to stay at Q0 itself. So I retain state at Q0 until I'm getting A's. So the way I would write this is, I would say A, and if the top of my stack is a Z, then we need it to go to an A and a Z. So often what we do is we denote stack symbols with uppercase alphabets because as we'll see later, they correspond to our non-terminals in the context-free grammar. So I'm saying that if I get an A as my input, a small a as my input, then and if the top of the stack is Z, then the top of the stack now becomes AZ. So my stack becomes something like this, a Z here and an A on top of it. So that's what my stack would look like after I get my first A. And another condition that I want to have here for the input A itself is, if the top of the stack is A, then I want the top of the stack to have another A. So I want to push an A on top of the existing A. So that's how my Q0 self loop would look like. And as soon as I get a B, so if my input is a B, I want to move to a new state, Q1, and what I want to do to the stack is, my stack is now going to contain an A, and I want to pop that A. So I'll say that the A goes to epsilon. What that means is, if I have, let's say, something like this, I have a Z, I have an A, I have another A. So what I'm saying is, this A on the top, this now becomes an epsilon. So effectively this just gets removed. So this gets removed from here, and now my stack will just contain one A and Z. So that's what I'm saying when I say that the stack top goes from an A to an epsilon and I move to Q1. Now until I keep getting B's, I want to stay at Q1. So I have a self loop at Q1 with a B, and my stack top should be A, and my stack top will go to epsilon. So I'm popping the top of the stack. So this is my self loop for Q1. And next what I do is, I say that if I get a Z, so if I have my input from the string will be an epsilon, and for that the top of my stack should be Z, and that will go to epsilon, and this will take me to my final state, which is Q2. Now let's actually run this with a couple of strings, and you'll actually know that this works after we do that. So let's say I have the string AABB. So this does belong to the language. So what happens is, my stack goes something like this. I'll have a Z initially. Then what I do is, so this is my stack right here. So I have a Z initially. When I get a small a, I will perform this operation. So this is step 1. So my stack will now become AZ. Remember that the leftmost symbol is always going to denote my stack top. So next what I do is, so I'm done with this A right here, and now I have another A, which is this one. So I perform this rule, and now my stack becomes AAZ, because I added another A here. So this A is also done now, and now I encounter a B right here. So when I encounter a B, I check whether the top of my stack is an A. Yes, it is. and since it is an A, I I would pop that A from the stack, so my stack would now become AZ, and I would move to Q1. So I'm right now right here, and this is the rule that I took at step 3, and I can get rid of this B now, and then I encounter another B, which is this one right here. So what I do is I apply this rule, and now I need to pop another A from the stack, so I get this, which is just a Z. And finally what I do is, now I've run out of inputs on my input string right here. So this is my input string. I've run out of symbols here, which means that this epsilon is correct. I don't have any input for my string. And is the top of my stack Z? Yes, it is. So what I need to do is I need to pop that Z. So this is step 5 for me. And finally when I pop it, I'm going to be left with an empty stack. So my stack is now empty here, and also I'm at my final state, which is Q2. So this string does get accepted here. So that's how we can do a trial run of the automaton. So we know that AABB is actually accepted, and let me get rid of all of this. So what we'll do next is we'll look at a string that isn't accepted. So let's consider something like AABB and an A again. So the new string we are considering is AABAB, let's say. So this is the string that I'm considering. I'm right now at this A, and my stack contains a Z. So next what I do is, because I encountered this A and my stack is Z, I take this rule right here and I convert my stack to an AZ. So that's fine. I can get rid of this A now. I have the second A right here. So I take this rule this time, and my stack now becomes AAZ. No problem till here as well. And now I've encountered a B. So I take this rule at step 3, and that takes me to Q1, and my stack now becomes AZ, and I can get rid of the B here. Now I've encountered an A, and the problem is that from Q1 I don't have an A transition. So if my input symbol is A, I don't have a transition at all from Q1, which means that I'm now stuck. And when we do get stuck in a pushdown automaton, we say that the string is not to be accepted. So at this A right here, I can conclude that this string is not going to be accepted, because I got trapped at this Q1 state, and now I don't have any way out. So I would take it to the dead state or the trap state. So that's how this automaton works, and we have drawn an automaton for a to the power n, b to the power n, and tried it out with a couple of strings. If you want, you could try it out with some more strings. I hope you'll be convinced that this is indeed the automaton for a power n, b power n. And one thing that I want to mention in this video itself is there are two conditions for a pushdown automaton accepting some string. So let me just write those down here. The first condition is acceptance by final state. So we of course have acceptance by final state. So if at the end of the input I am at a final state, then of course that string will be accepted. There's another condition as well, which is acceptance by empty stack, which means that what we are saying here is that if at the end of my input my stack is empty, then also I accept the string. And it so turns out that the way we drew this automaton, our stack was going to be empty and we were going to be at the final state both at the same time. So both of these just become equivalent to each other, but that need not always be the case. So I just want you to remember that these are the two acceptance conditions for pushdown automata, and there might be some cases where these two will be different, and we'll look at that in subsequent videos. So I'll see you there. Until then, don't forget to give this video a like, subscribe to my channel if you haven't already, and share the video with your friends. See you next time.